and
See,
not working. So hence the
also
Sunday
very,
batch. So
very,
just like how we have assignment,
you want to start and
even this module
go
has
ahead. Yeah.
assignment which we will just quickly brief you on what needs to be discussed with the students, and he will also share may not be tomorrow, maybe whenever you can just share the guidelines also for the assignment. So what should be written after that? Okay, so that
Hello,
students
everybody. Can you hear us?
Simi,
Yes, I can hear you.
Hey, Nancy. Good to see you are there. Ravi is here as well. Manya is here.
I'm
Soumya is
really
here.
sorry, guys, but they always surprise me with the workshops on working days. So that's why I was late. I was jumping from another meeting.
Okay, Manya. And really, we appreciate all of you joining us here for spending your time. But this is for your purpose. And today we are going to have workshop on descriptive statistics, scale and descriptive statistics, and our faculty is Professor Dr. Shankar Subramaniam. He is going to take us through in this particular journey. We are also joined by Professor Dr. Jivananda and Professor Dr. Diwal along with us, and Simi is also there to help us. So this particular topic is very interesting. Many of you are having query about the quantitative research, and this is what is going to help you in terms of designing your quantitative research, in terms of carrying out your quantitative research. So try to understand the concepts. Many of you know, many of you, I'm not saying you don't know, many of you are knowing it, but then if you are knowing it, you are enforcing what you know, okay? And what you don't know, you are adding to that layers. And then the concepts wise, yes, and then the application of the concept. That is very, very important, interpretation of it, because the quantitative research is sometimes people get a little bit scared, they're a little shy of doing, but qualitative research, people come up with the subjective assessment of various things, okay? But then that's the gap what we have seen, and we have previously also we have brought the workshop on quantitative research, and today also we are bringing it up thanks to Dr. Shankar, who has come forward, who has designed everything, the content and the delivery part of it. He himself is a prolific writer. He writes quite a lot of research articles along with the student, and published quite a lot of paper, including Scopus, as well as he's our research supervisor. He's our senior faculty. So, and he understands the gap, and he came forward and he said that, look, okay, we can have a workshop on that. So this is how we actually conceptualized, or we have the idea of taking you guys through in quantitative research, refreshing your knowledge, refreshing your idea of applications of this, where you can apply, how you can apply, what are the tricks, what are the tips. So all these things will be very clear through this workshop. Okay, this is more practical in nature, and we are going to have the part one today, and then we'll be having part two in very near future. That Simi will schedule and let you know, because we have not given you so much of thing for consumptions, because it will be too much for you guys to digest if you are not from quantitative background. So that's why we have divided it into part one, part two, like that, and we will be covering it. So without taking much of your time, I'm giving it to Dr. Shankar, welcoming him to start this particular what you call workshop. Thank you so much. Once again. Over.
Thank you, Dr. Abhijit, for the intro. Hi guys, good afternoon. So let me start with the presentation I have. Okay. So the questions, I think you can write down or put it on the chat, because when I am full screen, I'll not be able to see it, but I will handle it side by side. Maybe Simi can coordinate that. Okay. So basically, you're looking at descriptive statistics. Okay. So first of all, let me get an idea on what is statistics. So statistics is data information we have. So it can be anything. It can be in pictorial form. It can be a voice. It can be anything, but ultimately converted to numbers, figures. Okay. So the beauty of data is it can be in whatever sense, but it's totally dependent on the receiver, the user, to have a perspective. Because whatever data is wanting to say, it has its own language, I believe. It speaks out a lot conveyed, but if you are not able to pick up what it says, then there's a shortage. The fault is on our side because we're not able to interpret what it's saying. Okay, so with that brief, I'll just go into the little bit of introduction before we actually take up some research work or some data and then try to analyze it. And we'll carry on forward to the next also. So when you're saying statistics, so statistics is the science of collecting, organizing, analyzing, interpreting, and presenting data to support decision making under uncertainty. Okay, so it can be, as I said, in any form. It needs to be converted finally into the to come to a decision to the process where it's understood by you, so you can draw some decisions. So the whole purpose is to summarize large amounts of data into understandable forms. That is, could be, for example, averages, percentages, charts. Okay, so any of these can be done. So depending on what kind of understanding you need to build up on, and to basic idea is to identify the patterns or trends within the data, because that's very useful in business. We'd like to understand what it says. As I said, it speaks a lot of things, but if you're not able to comprehend it, it'll look like a useless data. But any data is saying something. Even a missing data is saying something. So it depends on you what kind of perspective or what kind of stage you are to actually have a look at it. And of course, it can lead to making predictions like in predictive analytics, or we can take informed decisions using the evidence. So we can formulate hypotheses and validate the research findings using statistics. And this is very objective because what it guarantees is there's only a one outcome, and whoever is repeating or you want to repeat it yourself, you'll come to the same outcome. So in that case, it's very, very objective than a subjective as in qualitative. So qualitative depends on the interpreter, how or till what level or depth you want to go, and it may vary. Okay, so that's a few sense of benefits you have with the statistics. So the scope of statistics obviously is applied in fields such as business, could be in healthcare, education, psychology, economics, and engineering. Covers both descriptive statistics, that is description, it says it describes the statistics, so it's called descriptive statistics. Okay, and the other one is inferential, so you can infer something. So that's the next part. So when you're looking at descriptive statistics, you could look at the mean, median, the charts. Inferential statistics could cover the confidence level, the hypothesis testing, formulating of that, and then looking at other outcomes of it. And it encompasses both the qualitative and quantitative analysis. Okay. So descriptive versus the inferential statistics. As I told you, what's the difference? Is descriptive is describing the statistics or the data you have, looking at the patterns, looking at the trends. Okay, so it describes a certain amount the data what you're looking at. Inferences is inferring from the data, so obviously it involves a certain amount of processing of the data to be set in tables or charts or whatever, so that you can take a inference or you can infer something from that data, and to the old this thing is to get to a decision. Okay, so that's the difference. So when you're looking at descriptive statistics, refers to the methods for summarizing, organizing, and presenting data in a meaningful way So the purpose is to describe the main features of a data set, to simplify large amounts of data into understandable summaries, and to provide a foundation for further statistical analysis. So this is very simple to look at and probably remember, because prima facie the definition is not so important as what you could expect the outcome from statistics or descriptive statistics. So what are the key components? So basically looking at the trends or the patterns. So measures of central tendency, that is the mean, median, mode, is the major part of it. And of course, the measures of dispersion, how the data is dispersed, what's the variance, what is the range, how it's dispersed vis-a-vis the mean. So that's standard deviation. And of course, the graphical tools like bar charts, histograms, pie charts, the box plots, or scatter chart, as we call it, to check out the outliners. And the tabular displays, the frequency tables, the cross tabulations. So this is all part of the descriptive statistics. So populations and samples. So when you look at the definitions and examples, then you look at obviously the population, the complete group of individuals, items, or data that you would want to study or draw conclusions about. So for example, all university students in the UAE would be a population. The sample is a subset of the population selected for actual analysis, used to make inferences about the population. So you can't actually study the whole of the population because it may be time consuming. So statistically, we see what is acceptable sample within that. So we got something like a sample size calculator or calculation to be done. Statistically, it says that if you work on this sample for the whole population, it's represented. And whatever inference you draw of the sample can be extended to the population. So that's part of the statistics, and it's very objective. It comes from fixed formulas. So let's say example, 200 students selected from 10 universities would be a sample. So stratified sampling, as we call it, because then the students we can do maybe select 20 students from each. Okay, likewise. So why do I use a sample? Because this is part of your research work when you're going to get involved with this terminologies and what you call terms. So just making a prima facie what do you call reference to that. So studying the entire population is often impractical due to time, cost, or accessibility. So proper sampling allows researchers to estimate characteristics of the population with accuracy because it's proven statistically, and we got formulas on which the sample size can be calculated. Okay. So qualitative versus the quantitative, and we call it as continuous versus the discrete. So these are some of the terms which you will. So qualitative, as we say, is we're looking at the quality, we are looking at the depth of the data. So quantity is looking at the volumes or the figures. Okay. So in simple terms, I'm saying, I mean, we can keep going into various aspects of it as we come to that. So continuous data it's on a continuous thing. And discrete is you have a band and then there's a gap and then band again and so on. So that's discrete data for you. So when you look at the aspects, let's say if you put it in a tabular form, so qualitative, quantitative, how they compare against each other. The definition is describe the categories or qualities or going in depth. Then quantity is obviously looking at numbers, represent numeric quantities. Data type is categorical, and there it's numerical. The subtypes are basically nominal and ordinal, and in quantitative is discrete and continuous. So examples are, if you're looking at gender, for example, male, female, so you're looking at separate things. So it's a category. So marital, that married, divorced, or married with children and so on. So it can be the status and the eye color, for example, blue, green, or black. Nationality, another example. In quantitative, it's a age, height, for example, exam score, income. So it can be discrete, it can be continuous, both. Okay, so measurement scales is generally the qualitative is nominal and ordinal, and the quantitative we can take a look at the interval and the ratio. So statistical tools, generally the qualitative, we are looking at the mode, frequency, tables, bar charts, the pie charts, and quantitative, we are referring to the mean, median, mode, standard deviation, histograms, and so on. Okay, then continuous variables versus the discrete variables. I would like to give you some examples of that. So continuous variables can take any value within a range. Like for example, the height of a person. So let's say from 100 centimeter to 200 centimeter. So anything can be a range. So discrete can take only discrete separate values, usually integers. Okay. So that's the difference. Then in terms of values, infinite possibilities between the two values. It's countable finite set of values, like in numbers, number of people, count of people, so on. Okay, so that's discrete variables. Then examples are the height, weight, temperature, time. So here in the discrete, you have number of children, books read, cars owned, and so on. So continuous variable can be a fractional, that it can be like 50.5 centimeters, for example, or 70.6 kgs, so on. Okay, whereas in discrete variables, it has to be an integer whole sum. There's so no question of any fraction. And then when you use visualization to get a better insight. So generally we use for continuous, it's histogram and the line chart. And for discrete, we can use the bar chart and the frequency tables. So next is we need to understand what are the scales of measurement. So we call them nominal, ordinal, interval, and the ratios. So we'll quickly delve into each of these. So nominal scales are basically categories within the order. So example, gender. Okay. So they are categories without any order. So it is like, it can be male, female, or female, male, so on. Okay. So they are used for classification and limited calculations. Labels have no real or actual value. They're used for qualitative variables, no logic or alphabetical arrangement. So they are not in order. They can be in any order. So there are different categories as such, and does not tell rank or interval. Okay. So next is the ordinal scale. So it's ordered categories without equal intervals. For example, if you're looking at the satisfaction levels of a customer, for example, so it can be very poor, average, good, excellent, and so on. Okay, so that's ordinal scale you're referring to, and they need not be equal intervals. Okay. Then interval scale, equal intervals without the true zero. Example, the temperature. Okay, so that's the interval scale. So next is the ratio scale. There are equal intervals with the true zero. So examples are the age, height, weight, so on. Okay. Then we're looking at the measurement examples, that is assigning scales to the real world data. So we're looking at, let's say, real world, like you're looking at variables data like gender, satisfaction level, temperature, age, exam grades, nationality, income, number of children, height, and date of birth. Okay. So when you look at gender, so we can categorize as per the definition, it's a nominal scale because it's a category. So categories with no intrinsic order. So it can be male, female, or can't be said, or transgender, whatever, if you're looking at that. Then satisfaction level is ordinal. So it's ranked order, like you start from unsatisfied to fully satisfied. So ranked order, but intervals between the levels are not equal. They are not equal. They don't convey the sense of equality. So temperature in Celsius is an interval. So equal intervals, but no true zero value. Okay. Age is a ratio. So equal intervals and zero means and absence of age. So if you're not looking at the age. So exam grades is ordinal scale. So like we say A, B, C, D as a grades represents the ranking, but not equal differences between the grades. So nationality, for example, is a nominal scale. So categories without any inherent order. So income in dollars or AED in any currency is a ratio. It's numeric with true zero, allows meaningful ratios. Example, twice as much. Okay. So number of children, discrete ratio, countable whole units with meaningful zero. So height in centimeter, continuous ratio. So numeric, measurable, and zero indicates none. And then if you're looking at date of birth, so definitely an interval, it's a calendar format. So time intervals consistent, but no true zero here. Okay, so these are some of the measurement examples to understand what is the nominal scale, ordinal, interval, and the ratio scales. Okay, so why scale matters? Obviously, choosing the statistical methods is based on the scale types. For example, when you're looking at nominal scale, the nature is categories without order. So frequency count, mode. So generally we use the chi-square test, the bar pie charts. Okay. The examples are the gender, nationality, blood type. These are some of the examples. The ordinal scale is the ranked categories. So you're taking a look at the median, percentiles, rank correlation, Spearman's row. Then the satisfaction level, socioeconomical status. Then we're looking at the intervals, the ordered equal intervals. So we're looking at mean, standard deviation, the t-test, Pearson correlation are examples of the statistical method. So knowing what scale you're going to use and what it means, like whether it's a nominal, ordinal, interval, so that will decide to some extent the statistical methods you're going to use. So it's indicative of that. So for example, this is given very straightforward. So if it's an interval scale like a temperature or dates, so we can look at the mean, standard deviation, t-tests, the Pearson correlation, and so on. And then if you're looking at the ratio scale, the ordered equal intervals are the true zero, all interval statistics, coefficient of variation, the geometric mean, and then you have the age, height, weight, income. Okay. Then the descriptive statistics overview. So key goals of descriptive statistics is summarize large data sets clearly and concisely, organize raw data into meaningful categories or visuals, describe the key features of a data set such as central tendency and variability, and then prepare data for further statistical analysis. Okay, that is for the future inferential analysis or statistics. So the summary of processes generally is the data collection. So you gather raw data through surveys, experiments, databases, etc. So next process is the data cleaning. So you need to handle if there are missing values. So you're able to detect the outliners and take them out to make it accurate data, because what input, if the accuracy of the input is good, the outcomes also will be accurate. Otherwise, you'll have issues. Then how you can tabulate the data, use frequency tables or cross tabulations to organize the data. And of course, the visualization will help to have further insights, that is create graphs like histograms, bar charts, and the pie charts. And the statistical summaries are the central tendency, mean, median, mode. And dispersion will basically look at the range, variance, and standard deviation. Okay, so before we go into any further, I'll take some questions so that I know that it's sinking in. So any questions you can put on the chat or any questions, or maybe if you can raise your hand, Simi can make you audible. Any questions? Because this is just the basics. Why it's required is because if you're looking at data, as I said, data says a lot of things. So how you're going to look and interpret this data will all depend on what type of data it is. So that is what the introduction is. So at this stage, you have any questions? Because this is related to your research, so we'd like to take some questions before I go further.
Yeah, I think, guys, this is the opportunity for you to clarify if something is clouding your thoughts or some of the areas where you feel you need to understand. Please come forward. Please ask your question. You can come through the chat box. I'm watching chat box, and I can help Dr. Shankar in terms of giving your questions or forwarding your
If
question.
if
And you
if I could just
ask
ask a
through you.
question.
Yeah, please go ahead.
Sorry, I'm struggling with my connection. I really am. Dr. Shankar, just Likert scales. If you've discussed it in depth, please ignore what I'm asking. But it is an interval. It's interval data level. Is that correct?
Yes, it's
Okay,
interval, and it's like the what you call as the ordinal data, because it's got a rank.
correct.
Okay.
So what statistics become available? Because interval data
So problem
is
there
valuable.
is like the satisfaction level I talked of.
Mm,
Okay, so descriptive statistics can only give you to some extent a minimum indication of it, because if you look at the mean, for example, so let's say I call the Likert scale, we generally start with the most negative. So you said
that's right.
unsatisfied, okay, strongly not satisfied, then you say less satisfied, then neutral,
Yes.
then satisfactory, and strongly satisfactory. Okay, so you have a
Yes.
5 scale Likert scale.
That's
Similarly, any scale you can use, but
That's right.
generally we stick to 5 because 7 is 2 more and 3 is very less for giving
Yeah.
detailing. So when you're looking at this, so let's say I'm looking at what is the mean of this, and it comes to, let's say, 2.5. Okay, so on a scale, so it's tending towards neutral. Okay,
That
so most of the data is saying it's neutral, but you cannot infer anything much on this. So
but
there,
yeah,
for the Likert scale, it will go more into correlation, which we are not come to that stage.
I
I've not
understand.
covered it still. So it's a
No,
it goes more
yeah,
into inferential.
I understand. And we assume the intervals are constant when we do statistics, when we
Yes,
do
we
quant.
think, yeah, we assume it for our sake, but generally that's not the criteria, because we don't know how strongly
Correct.
the person agrees or disagree, but still you're giving him some leeway, because if it's a yes or a no, it's absolutely cutting his wings. So if you
Yeah.
give him slightly more scale, so he's able to express his feelings, but still it is not, if I say, let's say, strongly agree, and you say strongly agree, maybe the depth is
Could
not
be
the same.
correct. Okay.
Okay.
Thank you, sir.
So it's not a
Thank you,
equal,
sir.
it's not equal in that sense. Yeah.
Thank you. Thank you very much. Thanks for clarifying.
Thank you, Dr. Diwal, for asking questions. Guys, I hope you can understand from these interactions what Dr. Diwal and Dr. Shankar had. And he clarified about the Likert scale, which is so much popular in terms of doing your quantitative research and bringing the thoughts together. So I would appreciate if you have some questions at this stage to ask, or we can continue, and then if you have questions at a later stage, we can ask that. Okay? So over to you, Dr. Shankar. I think they are
Okay.
not coming forward with the question. They will be waiting for you to move
Okay. So
further. And
maybe I can
yeah,
confuse them with some data, and then the questions will start flowing, because
I
this is only theory.
yeah, going
Okay,
to
so let's share some data so that they get a
that.
indication of what's coming.
Yeah,
Okay.
that would be it.
So, yeah. So this is sharing. All right. Let me get out of the screen. Okay. Can you see the screen now?
Yes.
Can you see the screen? Yeah.
Yes.
Yeah,
Yes.
yeah.
So let's say you have data, something like a data set like this. It's typically saying age, iteration, for example. Okay. It's talking about over 18, then over time, given the percentage salary hike, performance rating, relationship satisfaction, standard awards, no? Then stock options, total working years. Okay, so it's basically looking at HR data, for example, of a company. Okay, and this is typically the way to look. Okay, so it will have many of these, like business travel of the person, the daily rate, which department the person belongs, how much they are traveling from home, the education levels, okay, the education field, then looking at the employment count, the number of people. So it can be used data, it can be less data also. For example, this is having a data set which is about 1470 employees. Okay. So if you have a data set like this, so what do you think? How will you proceed? So since you're not asking the question, let me tickle you to say something. Yes, you can chat, or Simi can, there's some person asking a question.
Yeah,
Can you open
Alan
your mic? Yeah.
has raised his hand, Dr. Shankar.
Yes,
Yeah.
so you can
Uh,
open the mic. Yeah.
So the question how to proceed, I think I think part of it is to classify it as per the classification you have just mentioned, classification criteria of the data ranges and data types.
Mm-hmm.
So
Okay,
in a
fair
way that
enough.
allows you, in a way that allows you to look at the data from different perspectives.
Okay. So the first thing I would do is probably when I get data, I will see what it means. Okay. Because sometimes the data lands up on your lap. You're not aware of what data is. But here I'm already classifying, saying that it's HR data, looking from the table itself. What is the content of the table? Okay. So that will give an indication. So obviously there'll be a lot of areas which you like. Departments is discrete. Okay. So obviously you can put it into various categories, like you said, but that will be the a later stage actually. So what I would like to see here is, the first thing I will see that how big is the data. So employee count. So here, if I'm going to look, I can take a count, I can mark this, okay, and say is equal to count on Excel and put the bracket. Automatically it will count and say this much is the value. Okay, so basic Excel functions is able to give you certain indications, so you know how big the data is. So of course, also I would like to see whether there is any missing data. So you can cover the whole thing and put is equal to blank, and it can tell you how many fields are missing. So how you're going to handle the missing data is another thing you would like to know. Yes, you're putting, someone is raising a hand. Yeah. Please ask your question.
Yeah,
Simi, can
it's
you?
me
Yeah.
again. It's me again. I wanted to also to add that you've mentioned something about data cleansing, which I believe will follow what you have just listed.
Yeah, data cleaning is still the next stage. I am first looking at the data. I'm just inferring how big the data is and what is possibly the data saying. That's very important for you to understand, because that's your first instinct. So I will, as a analyst, will not just straight away jump onto data and start doing things. Okay, so that's it's a wrong strategy. First of all, I would like to look at the data and see what it is saying and what can I do with this data. You formulate your strategy, only then you land up anything. Otherwise, you'll be doing all sort of things and all sort of outcomes, and you'll get totally confused. That normally happens with most of the guys in research. Okay. So, there are many things you can do. but what are these things and how systematically you can do it is something you need to formulate a strategy for yourself. So first thing, I will look at this data. I'll say, okay, how big is this data? Whether there are some missing things, and probably even I don't know how this data has been collected. Okay, maybe the HR has this data, they're given it, because there are some things which are in different codes also. So here, for example, environment satisfaction is a Likert scale. So it's a mix of all scales. Okay, that's the next thing you need to, because you have the gender, but this is typically HR data, and this is how the HR would save the data. Okay, so as the employees come and join, so they write the profile, and this data is picking from the profile and putting in Excel. So that is why you get everything. So you have iteration. Iteration means someone leaving, yes or no. Okay. So like that. So the first inference is your gut feel about the data. So what it is, what I can do with this data, what are the things which will matter to look at and do from this data is what I'll first wonder. So I'll spend quite a time, maybe half an hour or so, because it's quite a sizable data. Okay, you have so many columns, so many, like you have the job roles, you have job satisfaction given, then you have marital status, monthly income, month monthly rate. Okay, now the number of companies worked before. So it's quite exhaustive. Okay, whether the person is over 18. Okay, what's the overtime? What is the percent salary hike? Okay, so this is typical data. This is for one. The second thing is you are collecting data from your survey, and that will also have a mix of all these things. So you'll have a demographic profile, and you'll probably use some of the Likert scale, maybe some text also. Okay, so that's why I've typically selected a data, and I will look at the data and try to make sense of this data. What are the things I could do with this data is what I'm trying to plan out first. Okay, then I will see what are the missing values. Then I would like to formulate into tables, organize them in a proper manner. Okay, then I will wonder now, what are other things I could do in terms of description? Like, for example, let's say the age. So I would like to know how young or old this company is, or in terms of your age of the employees. Okay, because that says a lot of things, whether it's a tech company. Okay, it can also, because looking at the job roles, I can think it's a pharma company. So I know that, okay, if looking at the age, I can draw some inference whether there are too many old people or too many young people. What's the kind of employee average I have? Okay, so that's one thing I can calculate. Then they're talking about distance from work, from home. So that might indicate maybe on whether the personal level satisfaction could come out of it. So because people get frustrated by traffic, by job satisfaction could take a beat if distance from home is too high. Okay, so likewise, you need to look at the data and think about what it is, and then of course you can classify that into ordinal scale, ratio scale, interval scale, Likert scale, all those. Okay, so I just gave this as an indication that these are the type of data you can have. Okay, so now I go back to the because this has induced some thoughts from you, so you at least made you talk, which is very my interest. Okay, unless you talk and ask me the questions, it's not going to uh, be a proper engagement. Okay, so now we go back here. So data collection, data cleaning, I explained a little bit. That is looking at the missing values. I can detect the outliners. So what do you understand by outliners? Anyone? So I would like to know that if all the data is cluttered in a particular manner, or you have some data which is too high and too low. For example, if let's say I'm looking at the income of the employees, okay, so the range it will come from the descriptive statistics. So I take a look, maybe here it ranges from 2000 to 19,000 dirhams or dollars or whatever. So obviously the range is there. Then you can do a box whisker plot. So that will give an indication of how the whole pattern is set. So if you have some one or two datas which are very close, like the MD is paid 19,000, for example. So he's not really removing him can maybe look at, because he's not really part of the analysis of the company. So you're basically looking at the major part is the middle guys who are going to matter, because that's the bulk. Okay, so I would like a pie chart, or I can have a bar chart to look at what are the spread. Okay, so things like that is the next thing what we do. Then we can ensure accuracy. Then obviously we can use tabulation, use the frequency tables, how many of what category, or cross tabulations, or how many people are living, or the number of people staying, and how many of them are males, how many of them are females. So that's an example of a cross tabulation. And does it mean anything to the data? So visualization is a create graphs like histogram, bar charts, and the pie charts. Then the statistical summaries, the central tendency, the mean, median, mode, and the dispersion, the range, variance, and standard deviation. So this is exactly where we summarized last. So I just showed you a glimpse of the data so that it can induce some questions from you. Okay, so going into further details of that. So that's the graph what we are looking at. So the key goals of descriptive statistics is to summarize the large data sets clearly and concisely, and organize raw data into meaningful categories or visuals. So describe key features of a data set, such as central tendency and variability. Prepare data for further statistical analysis. That is, example is the inferential statistics. Then core processes, statistical summary, mean, median, mode, dispersion, the range, variance, and the standard deviation. So then data cleaning is identifying, handling the missing values or the extreme values, which I explained to some extent. Okay, so we'll actually see how to do that. Then the central tendencies. So when you look at the mean, is always the average. So it's adding up all the numbers and dividing by the number of counts. So that's the average. And then the median, by definition, is you set the values in a particular order, from lowest to the highest, or from the highest to the lowest, whichever, and the central tendency of that. So if you got odd, you'll have a single number, which is the median. If it's even number, then you'll have two. So you add them and divide by 2 to get the median. Okay. So that's by definition the median. And the mode is the number of repeat cases. So number of times a number appears in the whole population. And then they have the range is the maximum and the minimum together. You separate that gives you a range. So obviously some of these will be typically used in particular calculations. Okay. So depending on your data, you need to look at it. So like I said, if I'm looking at age, so I'll be interested in the mean rather than the median. Okay. So if it's logical, maybe if it's normally distributed, the mean and median could very well match. So that also, if the mean, median, mode are about the same, you can easily say that it's a normal distribution. And also you can follow the normality tests which are available on SPSS. That's at a later stage. So most of the calculation statistics is applied for what you call as normalized data. So Normal data is data which is huge in number and it follows a bell curve. Okay. So statistics is typically based on this. So if there's a skewness in the data, so we have to make alterations, we have to make other adjustments for that. Okay. So that's also a valid point. So certain tests are valid for when most of the tests are valid when it's normal data. And if it's not, then you cannot apply the statistics. Okay. So I can't apply means the accuracy will be much less. So you can apply, but you cannot guarantee the outcome. Okay. So typically, when you look at the mean, so the mean or the arithmetic average is the measure of the central tendency that represents the typical value of the data set. It's calculated by summing all the values and dividing by the number of observations. Okay, so that's a simple thing. So when you do it on Excel is equal to average, mark the column of values or the row, whichever you want to classify. And that's it. And it gives you the value. Okay. Then looking at the mean, what is the mean or the use cases like education, for example, average test scores of students in the class. Then in business, average monthly revenue or customer rating. Healthcare average recovery time of patients, because you can infer something about this data. So it doesn't say everything, but there is some descriptive angle to it. So finance average daily stock prices over a period. Then marketing average purchase amount per customer. So this is some of the areas where typically you use a mean. So median is by definition, the median is the middle value of a data set when the numbers are arranged in ascending or descending order. So it divides the data set into two equal halves if it's odd or even. So you add and then you get to the center point, and again it divides the same thing into two equal parts. So how to calculate? Sort the values in order. So in Excel you can order the ranks. Okay. So there's A to Z and the downward upward arrow. So you can use that, and Excel can do the setting for you in the rank, and then you select it, or you can say is equal to median and mark the array, and it will automatically do it in the back hops and it will give you the answer. So it actually sorts the value in order. So if n is odd, the median is the middle value. If n is even, the median is the average of the two middle values. Okay, that's what I told you also. And that's the example you have. The median is for the robustness of the outliers. So median is resistant to extreme values. So ideal when data is skewed or includes outliers. Okay, you can use, that's the time when typically you'll use a median. So you'll see that how many times the number is repeated, and then that's where you the frequency of number of times it's showing up, and that's the median. So highest value is the median. So it gives a better representation of typical value when the distribution is not symmetrical. So when you look at the mode definition and when it's appropriate, so mode is the value of or category that occurs more frequently in a data set. Okay. So data set may have one mode, two modes, multiple modes, or no mode at all. If all the values are unique, obviously you don't have a mode. So multiple modes can be like certain values are repeated 3 times. So you got 3 values of 3 times repeat. So you got a multi-mode and so on. Okay. So when do we use a mode? So when identify the most common value, when working with nominal or categorical or ordinal data, or when the mean and median are not meaningful, such as with the qualitative data to understand popular preferences, trends, or inventory demand. For example, like at scale, someone just asked. So the mean would not be really purposeful, but if I look at number of times people have agreed or strongly agreed, and it shows 60%. So obviously the mode is leaning towards the maximum, that is strongly agree. So for that criteria, I will assume that this is the indication of that category. Okay. So that's one way to look at how you can use the mode. So examples, most common shoe size, for example, is let's say 9. So generally you look at the stores, they will have a maximum of a size 9 because that's the growing, what do you call as fast moving items. So favorite ice cream flavor in the survey can be chocolate, for example. So the stores will obviously keep more of chocolate. So most frequent exam grades, let's say, is B. So you can classify that most of your guys are getting a B grade. So gender is a sample. For example, if more number of females, so it's more leaned or biased towards the female perspective. So that's when you look at the frequencies or use a bar chart, so most common value can show up like this. Okay. So next thing is when you are looking at comparison of the central tendencies. So the arithmetic average or the middle value is the median, the mode is most frequent value. Formula, sum of all the values, the count. So middle value of sorted data. So mode is most repeated value. So best when to use it. Data is symmetric, no outliners. So you go for the mean. Then when the median, the data is skewed or has outliners, then obviously when identifying the most common value, okay. Then sensitive to outliners, the mean is very sensitive because you can have a mean which is handling, let's say, a lot of a data which is too old. For example, olders more than 60, close to 60, and a few values in between and few values less. So the whole thing will get skewed towards the aged. Okay, so mean is not a very is generally not used when you're sensitive to the outliners. So when you think it's going to lean to a particular case, so it avoid, or mean is typically used when you're looking at voluminous data and you think it's normally distributed. Okay, so sensitive to outliners, generally median is not and the mode is not. So when you got data which is skewed, so I'll go for the median, and generally in the other one, the mode also. So data type is quantitative interval ratios. I would use a mean. So median I could use in quantitative ordinal, and the mode, the nominal, ordinal, and the quantitative data. So examples is the test scores, for example. So median I could use for the household income. Okay, then the mode of can be used for the shoe sizes, etc. So next is we are looking at the dispersion measures. Okay, the range, the variance, the standard deviation. So what it means is how the data is dispersed above the mean is what we are trying to look at. So these are the formulas, but Excel directly can give you is equal to standard deviation and mark the array it will give you. Or you can also use descriptive statistics as a whole bunch. So which we will see now. Okay. So range is what is the minimum and the maximum and between what the numbers are. And the variance of the data is what is the variance above the mean, and standard deviation is how the data is disposed on with the mean. Okay. So here what we do is we get back to the data set I have showing here. Okay. So here what I do is, let's say there are 2 or 3 things which Excel is very useful. Okay. Generally for making this calculation, because most of the softwares or anything you use, the backups is the Excel. Okay. So the next part, you have Excel, you have Power BI, then you can look at Python or R. So for all these, the backup is still the Excel. Okay. So it's only the algorithms which is varying that. Then the higher softwares are, you can use SPSS, and they go for PLS or Adenco. So these are softwares which can handle a lot of data for you. Okay, but basically the Excel is the basis. So if you excel in Excel, you should be good in statistics. Okay, so that's the general impression which is there. So when you look at the Excel, there's certain things you need to understand and look at, because Excel these days is also giving you something like analyze data. So if are you able to see the screen? If someone can say yes or
Yes, we
Yeah.
can see it.
okay.
Yes, we can see it.
Yeah. So using AI, Excel itself can give you a lot of stuff. Okay. So we just typically it can say that what is this data about and what you can do this with this data. Okay. So it gives you all this. It can show you more outputs. Okay. So this is only indication, but again, it's your own instinct and how you want to go about it is your own understanding. Okay. But you can get a lot of help from Excel itself. Okay. So this is one. Second thing is you make sure that your data set is working with data analysis. Okay. So here on data analysis, I can do a lot of stuff. I can do inferential, I can do descriptive statistics. This will describe the whole thing, mean, mode, median, everything. Okay. So how do I get this is if you are looking at your screen or you have your working on your computer, you just check whether this is available with you. So if someone is not having it, the latest version 2016 upward will have this automatically installed. If it is not there, if someone can say no, then I can tell you what to do. Just check your computer and open the Excel and then check this. Some of you can do that. I hope not everyone is on the smartphone.
Yeah.
So
Dr.
if this
Shankar,
is
there
appearing,
is, yeah,
if this appears, data analysis.
yeah, it is appearing on
Yeah.
your thing. But
No,
they
no,
are
not
getting
on mine, in your Excel, because you need to use it, no?
Yeah,
On
yeah,
your
yeah.
Excel, on your Excel screen, whether this is showing. So I'm asking the students to do just a
Yeah,
basic check. If someone
yeah.
is not having it, I can show you what to do to
Me-
induce
Yes.
this. Yeah. So if it's there, generally it will appear if you have a recent this thing
Yes.
of what you call the uh, worksheet. Okay. Otherwise, what you need to do is you click on the file. I'll just show you. Click on the file, go to options. Okay. Then you click on the add-ins and say you can mark it or say go here. So it gives you the option and this is what you can click all and say okay. So automatically this will appear if it is due to if it's not there and it's a latest version, it will automatically appear. Data analytics will appear and also the AI analyze data.
Mhm.
Okay, so this is a few things you could do. Next thing is I'll just show you. As I said, I can use Excel in many ways. So let's say I'm going to look at the average. So I need to, because this is one which I showed you, which you can readily use to get an indication of what it is. Okay. So I need to get out of this. Now I'm going to use, let's say I want to work on the age. Okay. So what I do is I can copy this to a new file. I'm just doing it purposefully so that it's very evident for you. Okay. So let's place the data here. The whole set. Okay. So you should make sure that it's 1470. Okay. It's copied everything. Otherwise the answer will not be the same. So I'm going very slow purposefully so that it's meaningful for you because as it's similar to mathematics. If you're scared of mathematics, you're going to run away from this. So we don't want that situation. We are trying to preempt you to, so you can say is equal to, okay. And that's the primary prompt for Excel. Then you look at the average, you want the average. So when you click on the average, it asks for, okay, it says what you got to do. Okay. So it asks for the numbers So I can mark from here, or I can mark the whole thing. Okay. So whichever you think is, sorry, it's gone out. I need to get out of this. So I say is equal to average. Okay, and mark the whole thing. So it will throw off the average. Okay. So here,
You need to double click on average, doctor.
yeah. Okay, and then you mark it. So this is the primitive method. So which is, so you mark it and then you say that, okay, and that gives you the value. So it's 36. Okay. So this is the primitive method. So the next one is using the data. So I'm going to use the data analytics. So I go for the descriptive statistics as a whole. Okay. And say, okay. So it's going to ask me the input. Okay. So just check whether your labels are there, or the first, you can mark the labels in the first row. Okay. Then you're looking at, if you're going for a new sheet, or you want to keep the output here, so you need to show where you want it. So let's say I want it right on the top. Somewhere here. So I mark it and say accept. Okay. Then I'm going to want summary statistics, confidence level, 95%. So keep this in mind, 95%, because a lot of emphasis on your statistics. Okay. So I'll come to that later. So mark all that and say, okay. Okay. So it will throw up the whole statistics. So this is pretty easy to handle. So you don't have to worry. It gives you the mean. It's same as what I calculated here. Okay. So median is 36, mode is 34. So now you tell me what is your inference on this. So range is 42, the minimum is 18, and the maximum is 60. So let's look and do some inferences on this. Okay. So now you tell me if 36 is, because we already classified as a pharma company. So
Can you
is 36 a good age? Yeah. Hello?
Can you redo it again? Because there's something missing in my understanding. It seems that the output should be something that I cannot control. So I need to see it again, please. Because it's
So
out
first thing
range.
is you ensure that you have this data analytics.
I'm sure, yeah.
Okay. Once that is appearing, then you can do this. Okay. I go to data, then I click on data analytics. Then I say descriptive statistics, double click. Okay. Then I say, okay. So it asks for the outputs. I just mark the whole thing. And I also mark where I want the output. It can be on a new page, or I can keep the same page. Then I'm going to take I want the summary statistics. I want the confidence level as 95%. This is generally used. Okay. So if you are looking at data like medical science or research in clinical, then this will, you make it 99. For normal research work like DBA and MBA, you keep it as 95. Then kth largest, kth smallest, that's the kututus, and say okay.
Perfect. Thank you.
So automatically it throws you all this. It throws you the age. It throws you the standard error. Okay. It shows the median, mode, standard deviation, sample variance, kurtosis, skewness, range, minimum, maximum, sum, count. largest, smallest confidence level is 95%, which you marked. Okay, so now tell me what is your inference? What do you think about this? So this is the thing what I analyze for the age. Okay, so very important for you to understand. Now I got the mean, which is 36. I got the median, which is incidentally 36 again. Then the mode is 34. Okay. So what do you think? Can we assume this to be close to what you call as a normal distribution? Because the mean and median are more or less similar, because it seems to be centralized, because your hypothesis level is also skewness is very less. Okay. So this is some of the things you can infer on. And obviously, if you want the exact values, you can do the normality test on your SPSS. So now what I want you to infer is basically I'll be able to use this data because it's normal standardized data. Okay, so I can use any of these formulas without any problem. That's what the inference is. The range is 42, and most important is my mean is 36. So what do you understand by this mean for a pharma company?
What is the negative rating? You package it as a
Yes, please, someone.
say that something I learned out of it. And this is
What's the inference you can have? Because it's very important for you to understand how to use it rather than seeing what is the mean, median, and mode. So what it indicates, what is that you can infer,
say that
or what is that you can do about this? So if someone can tell me that. So we know it's a pharma company and the age level is 36. Okay, so even if you look at the data, you'll see that, okay, so it is showing all kinds. So obviously, okay, it's showing all kinds. So maybe what I can do is also I can insert the next thing is I can insert the charts for the same data. Okay, I mark it. I say insert chart. Maybe that can give you further indication of what it is. Let's say I use a pie chart. Okay. It's not coming the way I want it. Let's see. I mark the data. So this it's recommending all this.
أنا قاعد أفهم.
It's indicating the distribution, which I said is more or less a normal distribution. So here, basically, I want you to check is what is the way the chart is going about. Okay, this is not taking the way I want it. Basically, let me check 1 minute. Okay. The distribution of the data, let's say, yeah, just opening the other chart, which I already worked on earlier. So you can use that and not waste the time. You can check it out later. Okay, so this is the frequency you can use. Okay, and also the way it is. So it says that how many people at what level, because the ages category is no, because it's showing a continuous histogram. It will come as a histogram here. Okay, so it's a range. So from 18 to, so I can put the numbers on top. I can put the data labels. Okay, so that should give an indication. So you'll see that the 36 is somewhere here. That's 197. So pretty much half of this here and half of this here. So it is more or less a normal distribution. Okay. So that's why I said you can use most of these techniques here. Okay, so here I can put it in terms of percentile by using the percentile formula. So I say is equal to percentile and mark the array, and the first is 10%, then I get it, okay, and so on. So I get all the percentiles, and that I can convert to a graph here. So category, so I use the center point and I say that, okay, 35, so maximum is 606 people around here. So 606 and plus this, it's somewhere in between. So you see that there are a lot of people who are old in age. Okay, so these guys, like, this is almost close to 65. So these guys are going to retire. So obviously I had to find replacements for them. Okay, so for this, I need to plan talent acquisition for the next 5 years before they are 60. So these are some of the inferences which comes out of a normal age data. Okay, so going back to this is the data, same data which we used. Okay, so I just shown you what the mean, median, mode indicates and how you go about inferring this. So any questions at this stage? I'm more interested in the questions because I showed you the data, I shown you how to do this. Okay, so obviously how all of you are already doing some research, so you have some data.
Yeah.
I assume you have already gathered some data. So how do you handle this data is basically first you test it's normal so that you can use most of these formulas. Then which is the one you would like to use, the mean, mode, median, which is not very indicative of all this. Okay, so that you have to decide. Then you look at the scales, then for which I given the classification because this PPTs will be shared with you. So you know how to classify where to use what. So that's why I'm asking you again. So any questions at this stage because you're already handling some data.
Yeah, I need
Since
actually.
they
Excuse me, can I?
Yeah, please go ahead, Mudhir.
Yeah, I need your, I would say, judgment or observation on the chart that you showed just some minutes ago. Yeah, from my perspective, it's healthy, like having this age with this shape, having 36 in the company. I mean, 36 is the major age in the company, is healthy, right? Is there any perspective here to look at, or
yes, if I'm looking at the roles, salespeople and all, and I look at the spread of the roles, so for a pharma company, 36 is quite high actually. So I'll be looking at 30-ish. So that's internal external benchmark. So that's a different perspective, which again will come from experience. So, but you know that this is indicative. So even if it's 36, you like to, because you see lot of your people are retiring. So you will be acquiring younger people. So you'll try to push this 36 to 30. You understand? So as a HR professional, you like to be doing this. That's the perspective.
sure, but it is, I mean, it is like something special for pharma industry, or it's generic,
Yeah,
like,
this is for the pharma sector because this is linked to pharma. So
okay.
maybe if it's high tech, I'll still look at maybe 25. A company like Google or Tesla or Microsoft will look at 25s. 35 is too high for them.
Okay.
Okay, it's
I
the
have a
sector.
question.
Yes, yes,
Yeah,
please.
Yes,
Yes.
please. I
to
just wanted to ask about because you're dealing now with the age in this example, but when you mentioned data cleaning, you said, and it sounded a little bit subjective for me to be able to judge whether to keep in data or to avoid using any data at the extreme level. So when do we have to decide whether to remove the outliners or to keep them, and why? So now you didn't remove anything, and you just generated mean, mode, etc., and average. So when do we remove the outliners? When to keep them? Because it
Yes,
sounded a little bit subjective for me. What to
very,
remove?
very
What
good question. Very good question. I
Thank you.
understood. Just allow me to speak. Okay, I'll go back to the chart. Okay, so what I do is I'll build up something which is we call as the insert chart. Okay. So this shows me what is the outliner basically. So here I press chart. Okay. So scatter chart will also give me how the data is scattered.
In Jesus' name, amen.
Oh God. Isa, please, can you switch off your mic, please?
You are the problem of this, not us.
Isa,
Okay.
can you?
Problem. You are the problem, not us. You are calling us the problem.
Okay, please go ahead.
I can't.
Dr.
So
Shankar, please go ahead.
I'm going to use a chart which is called a box and whisker chart. So you see here, this is 36, right? That's the same figure what we got from here. So about this mean, how the data is oriented. So you see maximum orientation is this, okay? Whereas these are two extremes and very less data there. So if I was you, I will above 60, any case I would have removed and I will focus on this part. Okay, because
sorry,
these
Doctor.
are two,
Sorry,
these
Doctor,
are
how
outliners.
did you generate this? Sorry, I missed it. It was confusing
Yeah,
at the beginning. Sorry.
I'll show it again, no problem. So what I did is insert, because first I marked this, the whole data, because I'm inserting a chart like how we did for the bar chart and the histogram. Okay, I'm going to use typically a chart which we call as the scatter chart also will do, but this is not very clear because it will show a scatter chart is used to compare at least two sets of data. Okay, so we're not looking at that. So you go to all charts, you look for the box and whisker and double click. Okay, and then I need to label it. So I would like to know exactly what are the things which are showing there, the data labels. Okay, so this is the mean, right? Which is the same value as what we had, 36 point. You remember this value, 36.8224. Okay, and most of this is lying between 30 and 43. Whereas this 60 and 18 are outliers. There are very few people there, but as well as you can remove it. And if you're forming some policies, you're going to focus on this. Is that good enough to understand? Does it answer your question?
Yes, thank you, Doctor. It does.
Okay. So if you're looking at, let's say you're researched and find out, you gathered data and you find that let's say you're testing AI implications. So obviously you're looking at age group which matter, because the age group here need not be very conversant because it's beyond them already. So they won't know what is emerging technologies, what is AI. And these people below, they are using AI in a different way. It's more towards gamification and that. So they are not seriously involved in the business. So we can drop off. So it depends on what perspective you hold.
Is
So
there
here,
is there any way to remove those without going through each and every number in the
yeah,
data?
you can say what if.
What if? Okay.
If,
Okay.
what if, and remove it.
Okay,
You can
thank
say
you.
that, hold this, yeah.
Okay.
So all those is simple functions of Excel. So you can download from Excel. Microsoft gives you the guide for everything. So I'm only focusing on what you can do and the interpretation of that, which is more important because that is generally not available. Okay, that's why I was asking for the questions, because then I know what's your mindset. So any more questions, I'll be happy to take it at this time.
Yeah, there is one question, Dr. Shankar. It has come from, I don't know who is this guy, Kenulite Business Development. They're asking, is the range classified as a measure of central tendency or a measure of spread, or both?
Measure of spread. Range is measure of spread. It's not the central tendency. Central tendency is basically mean, mode, median.
Mean median mode.
So
Yeah.
it shows the pattern. You can talk about how it describes your statistics. Of course, the range is also descriptive statistics, but it's talking about the spread, because in certain areas you would like to know what's the spread. Like I would like to know what is the kind of income I'm paying or what kind of salaries I'm paying. So I can put a cap on that.
Okay, great.
Does
Thank
that
you so
answer the question?
Yeah, definitely it answers, because that's what has been given over here by Ken Lett. The range classified as a measure of central tendency or a measure of spread. You clarified it's a measure of spread. Thank you so much.
Yeah.
And
So
no
any other
further.
question?
No, I'm tracking the chat box, but then yeah, Fatima, I think you have answered that. How can we generate pie chart for age? Is it recommended?
Yeah, you can do it as the way I showed you. It's pie chart is not very meaningful for that in this case. So what's more meaningful is what I showed you, the bar chart and the histogram, because it is sort of a continuous data you're handling. Okay, so that was the other sheet I showed you here. So what I do here is I first take the descriptive. Okay, then I categorize this because there's too much to handle. So category is, let's say I'm looking at the first 10%. Okay, so I use the equal to percentile and mark the array and say 10%. And then I look at 25%, 50%, 75%, 90%, 99% to understand what's the spread. Okay, so how much in each? So I get a frequency bar chart like this. Okay, so a pie chart is not going to give you, because it's handling the type of discrete, it's not continuous in that sense. And here the histogram will also give you a good indication of the range. Does that answer the question?
Yes, doctor, thank you. Yes, it does.
Okay, so this is pretty easy to handle. So you say, no, this is the formula. This is equal to percentile. Then you mark the array. Then you say 10% here. You put it there and mark it in the, this is H18 is this cell. Okay, and so on. Then you spread it to 25, 50%. 50% is the mean. So you see automatically that is needed. 75% of the graph. So what you're trying to do is how the spread is happening. With 10%, there's only 26 of the values, 26%. So up till 25%, 30% is covered. So 50% is 36%, 75% is 43. The same thing as the whisker also was showing this. So if you notice on the whisker, the other graph, see here, 43. So this is roughly that. Okay, so it will very much tally with what you're doing. So that's one thing I will do.
Exactly.
Okay. And next thing is probably I will take a look at what is the distance in kilometers. See, as I said, the data sheet will indicate a lot. Okay, so first is the age. I would like to see how old or young is the workforce. So then draw some inference on that. So next, because it is leading to job satisfaction and things like that, I would like to know how these guys are traveling from home. So distance in kilometers. So I'll take a descriptive statistics of that. So I see that people are generally traveling around 9 to 10 kilometers, which is not very high. So that should not be any indication of a job satisfaction. And that also comes from the inferential statistics, which we will be seeing later. So if you look at the ANOVA single test, the distance from home and the iteration levels, whether that is leading to iteration, it is saying a no. Okay, because P is less than 0.05. So if you remember, I asked you to remember the confidence level 95%. So the balance is the margin of error is 0.05 or 5%. So if you see P is less than 0.05, so the hypothesis is the null hypothesis or the negative part of it, that there is no relationship between the distance from home and the iteration levels. Okay. So it is confirming that. Okay. So like this, you can use partly descriptive and partly inferential to draw inferences and look at what the data is talking about. Okay, so next is if I'm going to look at the income, so I do a similar testing. So I see the mean is around 6502. Here the range is important because you see the minimum is 1000 and the maximum is 19,000. So you have a whole stretch. So this is referring to areas or they're not part of your policy making. So here, obviously, I would like to have a whisker plot done. And if I'm going to take any policy, I'll look at the bulk of the candidates in center because I'm not going to take major decisions on the board or the highest paid guys and not on the lower guys. Okay, so it's somewhere from the lower middle to middle and senior levels, which is bulk of your employees. So that's going to have any substance in the policy making, okay, or any decision taken. So I do the histogram and it comes out like this. So you see the major portion or the pays are in this. Okay, so this you can benchmark against your what do you call the other guys who are paying and check whether they are paying something similar or you are on the lower side or the higher side. Okay, so that's another indication what you can do. Then I would like to check on the gender. So here it makes sense because it's a discrete count to get the pie chart. So I know how many males, how many females generally, and also I can look at how many males and how many females would like to be part of it. So that can also come from your AI charts. So if I look at the data and say analysis, so I can check out whether I can induce prompts here. I can say the gender, comma, what was the age, for example, you can say that also, and then give it a prompt. So it can show you that, and sometimes it gives you, so you're not saying that you're going to say gender and age or iteration, you can say gender, iteration, distribution. So you need to use proper prompts. So it gives you an indication. So here it's not taking that. So you need to work on your own. So, or you can formulate a question, how many highest value it's okay. So you can use, sometimes it gives you, sometimes it's not able to give you, then you use other things of that. Okay, so that's what I was showing you here. So I'm looking at the male, female, and then I'm taking a look at what is the marital status, whether that is showing any indication for your married and this thing. Okay, so if you're using the filtered table fields also, you can push a lot of these here, the X and Y, and I can change this also into different kind of graphs. So there's a lot you can do, which we will continue to discuss in the next one. So at this stage, I would stop here and ask some questions, take some questions before we end this session. And then in the next one, we'll go more in depth. Okay. So maybe I'll share this data set and one more data set because that one is from the research. So how do you do a Google search, Google form? Okay, then how do you come to the data, how you clean the data, things like that. We can also use that for the next one. So any questions at this stage?
Yes, if you allow me.
Sure.
I'm looking
And you're
here at the
very
data set, which
distracted
is rich.
because
Okay,
I know you're
too
sitting in
many
the lobby and
columns, too many
watching the
rows,
output.
and too many information
But
outside.
yeah,
And I doubt
that's
that
quite different.
you know,
But
in the journey of
one thing
collecting these
I have
information via Google Form or
a problem
whatever,
with is
you can reach this level of data
because
because finally the survey is something like 20 questions as a max, right? So, is there any way rather than surveys to collect these data, or due to the research limitations and something like this, we need to
See,
go
as I told you, this data is not from a survey. It is coming out from a profile. So when you join a company, you sign a form and you give all this data. So this data is basically picked up from there. So it's typically HR data. It's not a survey. Okay. So when you are using for a survey, for example, so it comes with your, what do we call as a conceptual model. So from the conceptual model, we try to formulate your questions, and from the questions, we go into a survey Google form and how you collect the data. So that I will, time permits, we'll try and cover next time.
Yeah, I mean, is the survey mandatory for the research, or we can find
Yes,
data
it
from
is.
research gates or something like this?
No. See here, when we are looking at a DBA level or any level 10 above, so we're looking at for primary data. So primary data is data what you collect, what you generate on your own. So whatever data you're using otherwise, which is not collected, is all of them secondary data. You're getting the difference. So you're supposed to collect data and then analyze that data. And the secondary data, whatever you have, you can triangulate that. Suppose you are looking at, let's say, this HR data, okay? So something similar you calculate and you come to inferences. Then I can also see, like, for example, let's say financials of a company, how they are doing. Then I can actually calculate and show from the financials of the company how they're doing. So I can triangulate from the secondary data. But primary data is a must. You need to collect. There's no other go on this.
Clear.
So primary data is not only statistics. You can do qualitative, that is interviews, transcripting, thematic analysis. You could do, or you could do a case study. Again, you need to generate primary data also there. So it has to be primarily a collection of data. You need to show that collection of data. So I think Professor Dr. Abhijit can add to this.
Yeah. Sorry, Dr. Shankar, please go ahead. What you're saying?
So he was asking me whether it's necessary for a DBA student to collect data or he can use secondary data. I told him prima facie we need to show primary data. That's the basis of
Yeah.
your analysis. So whatever, whether it's qualitative or quantitative or both.
No, actually, we prefer to adopt a mixed method approach in DBA because it is better to avoid only qualitative or only quantitative route kind of things. But definitely, we prefer to have some amount of mixture of both, actually, qualitative and quantitative. There you can decide, but
it involves primary
have
data.
mixed
You have to collect it.
is very much required when you are using the mixed method quantitative area. So primary data need to be there. Okay, so you can collect that. But if someone is doing exclusively on qualitative research and the research supervisors is also supporting that, is justifying in terms of adopting qualitative research, and it is serving the purpose, then he can go ahead.
So,
that.
Doctor,
But then
clarification is there also you're collecting primary data because you're conducting interviews, right? That's also primary data.
in qualitative also survey, interviews,
Yes.
all these things are there. So naturally the primary data are involved. So the statistical calculation will always be there, even though you are going for qualitative, because some element of quantitative analysis will be there. But our policy is that, not so policy, but we prefer And we tell our students to adopt the mixed method approach where you can blend the quantitative and qualitative both. And you can bring both the perspective in your research and make your research much more better in terms of developing or delivering the perspective of your research area.
So,
Did I answer the
Dr.
question?
Bose, so Doctor, the question is, the survey is necessary for collecting the data. This is, I believe, what was my colleague asking. So, and this is what the doctor was trying to say, that yes, it is mandatory to have a survey and for collection of the data if the quantitative method is requested.
Yeah, because you have to have some instrument to generate the data, and we insist that you should have the primary data, not just you can do entire research based on secondary data. Okay, secondary data, you can use it to supplement or to support that or to complement your areas of research. But then the primary data is very much required, and survey is one of the instruments through which you get the primary data. So yes, it is. Did I answer you?
Yeah, so it is a must, right? Like the primary data is a must through this research, right?
Because otherwise, how do you get the data? You know, to do
From
the
to make
quantitative
research
analysis.
is we can buy it from here or there. It's
Because
not so.
yeah, the secondary data analysis is already done actually by these things, and you are incorporating secondary data. You are inputting some of the things from the secondary data, which is quite of a supplemental kind of a thing, but not giving the kind of an age or the kind of depth to your research. Unless the primary data and support your research. And while collecting primary data, you need to use various instruments. Survey is one of that instrument. Did I answer you, Muzahid?
You did. Thank you.
Thank you. Thank you, Nancy and Fatima. Yeah. Over to you, Dr. Shankar.
Yeah, any more questions before we end for the day?
We are going for question answer round now. Before we end, any
Yes.
more questions, guys? But for your clarity,
So we will continue this for the next.
Sorry, Dr. Shankar.
So we will continue with all this in the next. So there I will proposing to show them how to, I will use survey data and then do the analysis also. So this time I was using the other data. Okay, so it will be more meaningful. So I can show them how to actually collect it, and then from there, yeah, output, and then from using the output, how to analyze. So we'll cover the Likert scale and everything in that.
Exactly. And the part one has built the necessary foundation, what we wanted to build in their mind. You know, many of them are having some of the concepts, but they may have certain amount of queries which got clarified in the part one. But in part two, as we are moving into the part two next workshop, there you will get more analysis. Okay, more managing the data. How do you manage the data minefield rather? Okay, how do you analyze the data? How do you collect the data and organize it properly? So all these things can be seen practically in part two. That's what Dr. Shankar is saying, that he will bring more perspective into your analysis part of it, and then moving into the interpretation part of it, that how do we go for the interpretation. One aspect is analysis, application of the statistical techniques, analyzing things, but then how do we interpret it? Okay, maybe we can give some example to it and help you to fine tune your understanding in that way. So that's why, thank you, Fatima. So that's why we have decided to go phase by phase, not we are not trying to complete it in one go, because that will be too much for you to consume, because this is very practical kind of topic, and you need to work. If you want to understand properly, you need to work as well, along with the faculty. So Dr. Shankar has already given, we will share with you all these data, the PPTs, what he has shared, including the Excel sheet and everything. But now that you got it, you also try it out at your end, so that you know the knowledge gets cemented in your understanding and applications part of it. And then we move on to the part 2 to refresh our thinking in that area. The more the calculations, analysis, interpretation, and all those kind of stuff. Okay, so that we will cover it in part 2. So you get chance to develop yourself and apply. That's why we have designed the workshop in phase manner. This particular workshop. Okay, and thanks to Dr. Shankar, he is ready. But then you also have to be ready. So that's why we have given this gap. Okay, so thank you very much. If you have any other questions, Ravi is saying we are clear. Doctor, thank you for the session. Thank you, Ravi, for attending. Thanks to Dr. Shankar.
Thank you so much, doctor.
Oh.
Thank you so much. Can I kindly request for the data that the doctor was using? Maybe we can practice what he was doing as well, if he
Yeah.
doesn't mind.
Yeah. It'll be, I'll send it to Simi and she'll share it with you.
She will share it with you. So anything
Thank
you
you so
need further, you please let, and we will help you. Don't worry. Okay, so as Dr. Shankar said, that we will share it with you. Simi will share it with you. And Divita has come back. Thank you, Dr. Shankar and Professor Vijay, for very useful workshop. Thank you, Divita, for your understanding and feedback, very valued feedback. Omozi, thank you. Elizabeth, thank you. Lulu has come. Thanks for the great session. Thank you, Lulu. Thank you, Fatima, for making it interactive. And thank you, Teresa. Thank you very much. All of you are so good student, actually. I remember enjoying my session with you guys. Okay, so thank you, Francola. Great workshop. Thank you, doctors. Thank you. So these are the things. Dr. Mania has come back. Thank you, doctor. So same to you, Dr. Mania. All the very best to all of you, and it's wonderful to have you all. And next session, you do some practice on these data sets and everything what Dr. Shankar has given you. Add some reading to it as Dr. Shankar suggested. But then when you come back to the next, you come prepared for more interactions. Okay, try to understand, because this is a golden opportunity. It's not that, who is making mistake or who is asking. No question is a silly question. So you can ask till the time you are clear about how to apply it. Okay, so that is why we are bringing this workshop, which is not lecture, which is more practical driven concept building kind of initiative. Okay, and then how do you develop the concept and apply it? So this is why the purpose is for
So
this workshop.
we'll be able to answer, or very glad to answer any question. That's
Yeah.
why I was throughout I'm asking what's the questions. So
Yeah.
next time you come prepared to give me more questions, so it'll be really more interesting.
Yes, Dr. Shankar, and that's what the feedback is also. They are very much, they have liked it. And Andrew has come back. Thank you very much. It was eye-opening. See how it is. People are now getting into the understanding of statistics and applications of it, calculation. Frankula is saying statistics is always a challenge. So I learned a lot today, especially the functionality of Excel that can help with data analysis. So Dr. Shankar, it shows the kind of contribution your workshop has already made to their thinking and the skill. So knowledge and skill, both the things are their
We are
feedback.
very happy to contribute and help out. Always.
Help out. Yeah. So thank you very much. Once again, we will be coming back with the part 2. And by that time, you should be prepared to ask more questions from Dr. Shankar. And once this part 1, part 2 is over, then you will be very good in terms of applying. You will no longer be afraid of doing the statistical things, and some of the practice will make you through. Okay. Thank you, Dr. Ephraim. Thank you, Dr. Shankar. Ephraim has thanked, and thank you very much. So all of you have a nice afternoon, day. And thank you very much, Dr. Shankar, for your wonderful.
Thank you. Thank you.
You
thank
are
you
always.
Thank you for giving me the
Enjoy your
opportunity,
session.
and I enjoyed thoroughly answering the questions, basically.
With your help. So all the very best.
Okay. Bye-bye.
Bye.